Right, okay, so
Hello.
hi.
Morning.
Morning, we're going to rush this one.
This one is
easy.
It's long,
Long.
but it's not really.
Long.
It's just more to do, I would say.
Long multiplication.
And then we're going to do long division,
Okay.
which, you know, actually we're not going to mention the word chunking at any point. Which.
To start with, yeah?
Okay, so what we're going to do is we're going to show you two methods.
Oh, we're going to do two methods?
Yeah, we're going to do two methods.
Two
because
methods.
in this world there are different ways to do things.
Oh.
And one of you might prefer Mr. Casey's method, and one of you might prefer my method, but they are both as valid.
They're both valid. One's an old method, because that's me.
That's the method that I used
and
back in the day.
Okay.
And this is
This is the new method.
This is the new method.
What numbers should we use?
Oh, let's go with 346
Yeah.
times 75.
Ooh, okay.
Yeah?
You first?
I'll go first.
You go first.
So, mine is a bit of a long setup, but once you get going,
it's lovely.
It's
I do
lovely.
like the method.
We just don't admit that to Mr. Massey,
Yeah.
really. So, first of all, if you're using square paper, this is nice and easy. I do actually suggest you use a ruler. You need to draw yourself a grid, which is 3 numbers by 2 numbers, because I am multiplying a 3-digit number by a 2-digit number. So I need 3 columns and 2 rows, okay? And that's my first setup. The next thing I do is I draw lines from the top right to the bottom left.
Diagonal lines.
Diagonal lines down.
And you extend them?
Yeah, we extend them out because when we are totaling, it's nice to have a space that shows our hundreds, our units, our tens, and all that jazz. So I write my numbers, 3, 4, 6, that's why I went 3 columns, 1, 2, 3, 3-digit number, and a 2-digit number there, okay? Now all I have to do is multiply. Now with this, all I have to know is up to 9 times 9. That's all I have to know, which is quite lovely, really. 6 times 7 is 42. I put my tens and my units.
Okay, so you've written the whole 42 in the first square.
Yeah.
But because the square's split by a diagonal, it's on either side of the diagonal.
Yeah.
Okay,
Then I've got 6 times 5. So that is 30. And then 4 times 7, 28. 3 times 7, 21. 4 times 5, 20, and 3 times 5, 15. Now that's completed now.
That's your working out.
That's my working out. I'm now going to add up my diagonals. Okay, so you see you've got your first diagonal here, the next one.
Okay, and the answers are going to go here. Should we do a different colour for that?
Yeah, definitely. So we've got just 0 in that first diagonal. Then 2 plus 3 plus 0 is just 5. 4 plus 8 is 12. Plus 2 is 14. Plus 5 is 19.
Yep.
Yeah?
Yep.
I hope so.
19.
Then we're going to put the 9 there.
Yeah. And
we're going to carry that 1 over.
Okay, to the next diagonal.
The next diagonal. 2 plus 1 plus 1 plus 1 is 5, and I've used that. And then I've just got 2 in that last diagonal. So my answer is 25,950.
Lovely.
I do love it.
It is very nice. I may end up doing this method because I do like this method. But
change your opinion.
Well, because I've been doing my method, which is the kind of more traditional way for so many years, because I'm so old. It's so many years.
I was taught this method,
it's very hard for me to
and
change.
I could never love it.
Okay.
I quite liked traditional grid method in comparison to this because I kind of could see what I was doing. Okay. But you teach me because I might have my moments.
It's not I'm teaching you.
No, you are, because I seriously would not be able to do this.
So I line up my units, a bit like when we're adding,
yeah,
and make sure everything's in the right place. And then I'm going to multiply the units at the bottom by everything at the top.
Okay.
And then I'm going to multiply the tens at the bottom by everything at the top. Okay. So I'm going to start with a 5, 6 5s, 30. So I write my 30. Now again, like with adding, I can't write that in one column. So I write my 0 and I carry my 3 into the next column. Okay. 5 4s are 20. And the 3 is 23.
23.
So I put my 3 in, and I carry my 2, the 20 part into the next column. 3 5 is 15, 16, 17, and I write my 7. Because I've run out of numbers now, I can't do 5 times anything, I can put the 1 there as well.
Okay.
Okay. Now I've basically multiplied 346 by 5.
Yeah, and you've got that.
And I've got that.
Done that. Check.
Now I'm going to multiply 346 by 70.
Right, 70.
But to make it easy, I'm going to assume that anything times 70 is going to end with a 0.
Yeah.
Yeah, 10 times bigger. So now all I've got to do is times by 7.
Okay.
7 sixes.
42.
42. Put the 2
There's
in.
that 42.
Carry 4. It's very similar numbers, but it's the
Yeah.
same numbers. 7 fours, 28.
28.
Plus 4,
Yeah.
32. And 3 sevens, 21. 24. So this is 5 times 346. This is 70 times 346. If I add them, I'll get 75 times 346.
Yeah.
The numbers.
I'm getting a sort of epiphany here.
No, they're kind of
Epiphany
very similar, aren't they?
I'm just like, this is beautiful.
0 and 0. Yeah.
Yeah.
2 and 3.
Yeah.
7 and 2. 1 and 4. 2.
Lovely.
Same answer.
Look at that. Now, I know that this is quite traditional in primary school to stick with column method, which is brilliant. You may have been like me when I was a bit younger and not enjoyed that. Although now when I look at it, I'm like, I have no idea why, because that makes so much sense. But you might not love column method, so therefore you might want to try yourself a new method. And if you're in Mr. Massey's class, you ain't got a choice.
No,
so
you will be doing this method.
You might as well get going with it now. But that is lovely. So what we'd like you to do now is we'd like you to do one yourself.
Yes, yep.
And you can choose which method you would like to do. So write this down, write that down, have that down on your piece of paper, because what I'm going to do is I'm going to flick back to the other slide so you've got your examples as well.
Yep.
So hopefully you've got that down now. Brilliant.
Flick back.
We're going to leave those examples there and you're going to pause the video now and have a go at that method.
We'll go away and have a cup of tea, I think. Okay, we're back. Hopefully you paused, otherwise that was a very short pause.
Hopefully you got your answer. So what we're going to do is we're both going to write our methods at the same time.
At the same time? That might be confusing.
Do you think?
Let's just do it, shall we?
Yeah.
And let's just see what happens.
Just watch the right person.
I'm kind of watching you.
I need a new colour.
Or should we change? Hang on, let me rub my beginnings out.
Lovely.
We'll both change colour at the same time.
Have a slightly smaller pen
And
nib.
a slightly smaller pen.
Thank you.
Is that enough for you?
I'm now less demanding.
So we get the same answer. Yeah, hey.
So hopefully,
Beautiful.
that's what you've got. Have a little look at my method, have a little look at Mr. Casey's method if that was your chosen method. You can rewind that and you can watch it again.
Oh yeah.
There's nothing wrong with that.
Watch that method, then watch this method.
You might, some of my lot in year 7, shout out to 7x1, they tried two different methods within the lesson. They were like, right, I'm going to do question 1, I'm going to try this method. And that's how you work out which one you prefer.
It would be good, I mean, from a mastery point of view, to be able to do both methods.
Absolutely.
Because there is a degree of understanding. As you do these methods, you actually see how the numbers work.
Yeah, it's beautiful.
So this kind of shows you the fact that it's kind of 4 times something and 20 times something put together. This does the same, but in a different sort of way.
It does it for you in a way. This one, if you struggle with place value, this one does the place value for you because of the way that the grid is structured. But what I also found quite interesting, watching, once I'd done the question, and then watching Mr. Casey do it, he did all the same times tables that I did.
Yeah.
Every single one was
Every
within this
single
grid.
one is done.
So they're not too different, actually.
No.
And at the end of the day, you're still using your times tables. So the next thing we're going to do is we're just going to do a bit of division.
Yeah.
Long
division.
Long division. Now, when you're at primary school, you do chunking. The less said about that, the better.
Miss Cheeseman doesn't like chunking.
I really don't. But what I do need to find is a question.
Okay.
Do you want to make up a question?
Well, hang on.
Because I don't feel like I can.
Okay. Yeah. Okay.
So
okay.
long division after
yeah.
long multiplication.
Yeah.
So
yeah.
let's do this one.
Right,
we're going to do 12,000
yeah.
and 26 divided by 14.
14.
Yeah.
That's an interesting number.
Yeah.
14, because I'm not too good at the 14 times table, and I know I'm going to need it.
Why don't you write it out then to begin with?
So what I always do, and what I always teach, is if I'm dividing by 8, I write out my 8 times table. If I'm dividing by 14, I write out my 14 times table,
yeah.
so that I have something to refer to. So it's one less thing to think about. So here I go. So 14, 2 14s are 28, 42,
yeah.
56,
yeah.
70, 84,
98,
98,
112, 126,
6 and 1,
40.
40. Now when I get to 10, I know I get to 10 because I've got 14 with a 0. So that's 10 times, and that's as much as I'm going to need.
Okay, so we're going to show you long division to begin with, and then we're going to show you something called short division, which you...
Probably is what you do.
Yeah, and all long division is short division, but writing out everything that you do.
Okay, yeah, very good.
So, I might just give myself a bit more room there.
Mm-hmm.
Okay, so what we're going to do is we're going to be writing everything out.
Oh, we're going to come down, aren't we? Yeah.
So, 14 goes into 1.
No.
No, it doesn't. It goes in 0 times. 0 times. So what we have to do is we have to work out kind of what we have left over. Okay, so we've still got our 1 there. Yeah. Okay, so we do 14 times 0, which
yep.
is 0.
Uh-huh.
And we minus it from what we've got left,
yep.
and we've still got 1.
Yep.
Okay, we bring down
the 2.
Bring down the 2.
Lovely.
And we're going to say, how many times does 14 go into 12?
No, it doesn't.
Still doesn't.
Mm-hmm.
So we do 14 times the 0, still 0, and we're still left
with 12.
With our 12. Carry down the next digit. Okay? Just make sure that everyone's happy
carry down
with that.
The next digit.
14 goes into 120.
Oh, now it does, because I can check that. Let me just quickly count them. I've got 1, 2, 3, 4, 5, 6, 7, 8, and then 120 is here.
So it goes in 8 times.
Mm.
So it's going to go in 8 times. Okay. We multiply to see how much we have left from our 120. So 14 times 8, that is 112. Okay.
Yep.
And yeah, we've got that from there. Yep. We're going to minus those to see how much we have remaining. We've got 8 remaining. Yep. And we're going to copy down
the 2.
Okay.
14 into 82. Now again, I can use this to find. So I've got 1, 2, 3, 4, 5. 82 is kind of here. Yeah. So 5 times.
So it's going to go. Oh, I need to just pop that up there.
You need a bit of board now, aren't you?
5. It goes in 5 times. 14 times 5, as we said, was 70.
Yep.
And we've got
a little bit of subtraction to do.
Bit of subtraction, which leaves us with 12.
Mm-hmm.
We copy down our 6, which is our final number.
126.
14 goes into 126.
9 times.
9 times exactly, which means I've got that there. 14 times 9, as we just said, it's 126. We minus that from what we have left, and we're going to get 0. If we get 0, we know we're done. We know it's gone in a whole amount of times without a remainder.
If we had a 0 here, which is, we'd have 0.0, we could pull that 0 down. We would just keep getting zeros, so there's nothing left.
0. Nothing left. It's gone in that amount of times. So that is your long division there. Do you want to do, give them one to do? Let's
give them one to do, and we'll try and do it on one page so that we don't keep going up and down, so we can see the elegance. Because this is quite an elegant kind of method. I do like the elegance of it all. Should we do 12?
Yeah, so 6, 8, 2, 8.
6, 8, 2, 8.
Divided by 12.
Oh, you don't like my curly little bits.
Curly Watsits.
Curly Watsits. Let's just get rid of the curly Watsits.
I just don't like it because it's like a square root. That's the only reason.
I know your reason. Your reasons are sound. Don't worry, I agree with your reasons. Just tradition. 12s, yeah?
Yeah.
Okay, so I showed before, I write out my 12 times table,
yeah.
just to help me look and see. So 12, 24, 36, 48, 60, 82, 84, 96, 108, and 120. 12 with a 0 on the end, that's quite enough.
Perfect.
Okay. So 12's into 6.
Doesn't go.
Doesn't go, is it?
0.
0. And 0 times 12 is 0.
0.
Yep.
Yep. So we still got
when I subtract
6.
those, and I subtract that, I've still got 6. I'll bring down my 8. 12's into 68. Well, that's 1, 2, 3, 4, 5 of those. So 5. And 5 12s are 60. So I'll put that there. And I do my subtraction, and I get 8 left over. Bring down my next number, 82. So 12's into 82. Well, 1, 2, 3, 4, 5, 6 times. 82 is kind of there, so 6 times. And 6 times 12 is 72.
Minus it.
Subtract that, and the difference between those is 10. Bring down my last number, which is an 8. 12 to 108 go 1, 2, 3, 4, 5, 6, 7, 8, 9 times.
9 times.
And 9 times 12 is 108.
Minus it.
Subtract them, and I get 0.
Which means
and
my
I've got
answer is
nothing left because I'd have to have lots of zeros.
That means my answer is 569. Beautiful. So that is long division. We're now going to show you short division, with the same questions.
Same questions? Excellent.
So let's go with that. Was it 6828?
I think it was. Yep.
Okay, so short division is the same, but we just don't write everything
down. We don't
down.
write it all out. We kind of work it out. I'm still gonna write this.
We still want those, definitely.
That can be useful, can't it? Because it saves me having to keep working it out. Something to refer to.
It makes it nice and easy, definitely, writing out your times table, especially if it's not one that you don't know off by heart. If you were doing this with 5s or 4s or 3s, you might not. That was my shoulder that did that.
Did you just turn the internet on with your shoulder?
Yeah.
Well done.
So 12 does not go into 6, and we've got our 6 still remaining.
So we don't do all this taking away stuff. We just pull our remainder
next to the next number. 12 goes into 68 5 times, remainder 8. I put my 8
now I know it's fast. I mean, I can quickly see that. 1, 2, 3, 4, 5, and in order to get to 68, I've kind of got another 8 to go. So that's my remainder. 12
goes into 82.
1, 2, 3, 4, 5, 6 times.
6 times remainder 10.
10 left over.
And 12 goes into 108. 1, 2, 3, 4, 5, 6. 9 times.
None left over.
And there's no remainders, so I'm done.
So in many ways, short division looks easier and probably is easier.
But
and you'll often find, I think,
subtraction is good.
And you'll often find that a lot of teachers will teach short division because it's quite quick, it's quite easy, and it looks quite nice. It doesn't look as complicated. If you go on to do any higher level maths, where you're dividing algebra, you will need to know how to do long division.
So we're going to ask you to do. We're going to demonstrate one using long division and one using short division, but you can choose whatever one you like. That is not a problem for us.
Any method you like.
So these are the two that we're going to ask you to do. So pause the video.
And we're back.
We're going to go through them now. So I think we're able to move this guy, right?
Yeah.
So that I've got a bit more room.
There you go.
Okay. So, shall I do short division and then you do long division?
Go on then, go on.
Okay, so I'm going to do short division for this one. I'm going to draw.
Do you want 8 times table? Shall I bung that out? Or should we?
Why not? So 8, 16, 24, 32,
40, 48, 56, 64,
72, 80.
Yeah.
Nice. Okay.
You had to think about that for a minute there.
Listen, quick. 8 does not go into 7, so I've still got 7 left over. 8 goes into 77 9
times.
times. 9 times remainder 5.
Yep.
8 goes into 50 6 times, remainder 2, and 8 goes into 24 3 times, and I'm done. Short division.
Short division. Short division, quite short, isn't it? Short division.
Yeah.
Long division.
Long division.
13s. Thanks for that, Miss. It's very
oh, it's nice though.
Prosaic.
13 times total.
13. So first of all, I'm still going to write it out in that same way that you did before. 9035. Oh.
He doesn't annoy me that much, I promise.
No, it annoys you.
It's got style. Do you know what? It's because I wrote it like that and I got told off.
Did you get told off?
Yeah, I can't remember who by, but someone told me off.
Some maths teacher told you off?
Yeah, some maths teacher told me off.
Never get told off about your style. Style is part of it. 13. Help me out. 26. 39. 52.
52. 65. 78.
It's 91.
91. 104.
117 and
130.
130. So that's all I'm going to need. There's 9 of those.
Okay, good.
See, even we had to think about that.
Of course.
Doesn't just
but
happen.
it is just adding 13. So
It is
because
just
you
adding
can
13,
do it, it might take some time. That doesn't mean you shouldn't.
No. Right, 13 into 9. I know that is just not going to go. Okay? And 0 times 13 is 0. And if I subtract that, I'm still left with my 9.
Yeah.
Bring down my 0.
0.
Okay, now I've got 90. So 90's here. Well, 90's here.
Right.
So 1, 2, 3, 4, 5, 6.
6 times.
6 times. So I'm going to put my 6 there. 6 13s would have given me 78. And if I subtract them, I'll find out what was left over. 12 left over.
Carry down your 3.
Carry down my 3. 123.
9.
9 times. Okay. And 9 times 13 gives me 117.
Which gives you a remainder 6.
Which gives me a remainder 6.
Carry down your 5.
Down my 5. And, oh good, 1, 2, 3, 4, 5. And 5 13s are 65. And when I subtract them, I get
0.
And then all I can now bring down would be more zeros.
Yeah.
Done.
So your answer is 695.
695.
Done. Lovely.
Long division.
Short division.
Short division.
Long multiplication.
All different types.
Enjoy.
Yeah. Master that and you'll be master of the universe.
Bye.
Bye.